Hello, everyone, and welcome to today's webinar. For those who joining us for the first time, my name is Alina Bonadonna, and I'm delighted to be a moderator for this session, especially with such cool speaker. Welcome, Dr. Byron Chaves, an esteemed associate professor at the University of Nebraska-Lincoln. Hi, Byron. How are you?
Hey, I'm doing pretty well. How are you?
I'm amazing. Where are you currently based?
So as you know, I live in Lincoln, Nebraska, but this week I'm traveling, so I am in a hotel in the state of New Mexico.
Nice, nice. Actually, that's a kind of my superpower to catch speakers on a go.
Yeah. I was a little worried about the setup, but it's going to work out just fine.
No, I'm pretty sure that everything will be perfect. And guys, before we get started, let's do a quick technical check to ensure that everything is working smoothly at your end as well. So you probably know that you have to just click on the reaction icon at the bottom left corner to your screen and shoot on as many hearts to Byron as you can. Yeah, probably there is nothing, or if there are other options to let us know that you are guys hearing us well, seeing us well, just drop into a question window that you are like fine to absorb new information. So Byron, are you ready to start?
I am. Let's do it. Let's talk about salmonella.
Yeah, let's talk about salmonella. I see already a lot of people actually coming from Switzerland, from Mexico, from where else, guys? Probably, yes, I see that. Okay, so a lot of people here already waiting for the webinar. So Byron, you're welcome to present this amazing topic. The stage is yours.
Thank you so much. So, can you confirm that you see my screen?
Yeah, all good.
Okay, and I'm moving the slides. Can you confirm that?
Yes, so I will disappear for a while.
Excellent. Well, thanks, Alina, for the invitation, and I'm really, really happy to be here with you this morning. For me, it is 9 a.m. in New Mexico, but I know that for many of you, it's a much different time later in the day. Happy to be here and share a little bit about the work that we do at the University of Nebraska and that my team does around risk management strategies for microbiological hazards. Like Alina said, my name is Byron Chaves, and I'm an associate professor at the University of Nebraska. This week, also, like I mentioned, I'm traveling, so always on the go. But this today, really, I want to share a little bit about risk management and less about the testing. And we'll talk a little bit about testing at the end, but you'll see why I didn't want to spend so much time on testing here in a little bit. Okay, the first thing that I want to, I want us to be on the same page about some definitions. And so the first thing is hazard, right? When we are talking about risk management, of course, we're talking about managing risks, and we need to define what risk and a hazard really are. When we think about a hazard, keep in mind that this is the actual physical, chemical, or biological agent that it's capable of causing illness or injury in the consumer if we don't apply controls to that specific agent, right? So basically what we want to do in the context of HACCP, of the hazard analysis and critical control point system, is to control, reduce that hazard, or eliminate it if we can eliminate it, which it doesn't typically happen. Sometimes we can only control it in a way that we are going to reduce the amount of units that have that hazard, and sometimes we can only reduce it to an acceptable level. Now, a term that is highly related to hazard is the concept of risk, but I really want you to keep in mind that these are different things. Hazard is the agent, and risk is the probability function that that agent will cause illness or injury in the consumer. And it depends largely on two things. It depends on the incidence of occurrence, right? How frequently do we find that hazard in the food product, right? In your product process combination. And also depends largely on the severity of the illness that is caused by that hazard. And I really want you to keep in mind, when we take HACCP courses, and I'm in New Mexico this week, I was teaching a HACCP course for meat and poultry processors. And I teach these courses all the time, and I go to companies, and we always use these sort of qualitative risk ranking matrices, right? And so we can combine the likelihood of occurrence with consequences, and you guys can tell that this comes from FAO, and this is a phenomenal resource. And at the end of the day, when we are talking about food safety management system, we want to classify the risk associated with the hazards as maybe low, very low, medium, high, very high. And from a management perspective, we want to use prerequisite programs such as sanitation, good manufacturing practices, environmental monitoring, supply chain controls, to manage the risks, the hazards that represent a low to moderate risk. And we typically recommend people and processors to include the high and very high risk hazards in their HACCP system, right? Because of course, of the seriousness of those hazards. However, keep in mind that when we are doing risk ranking, we can only work on the likelihood of occurrence. There's nothing we can do about the severity of the illness. We cannot change the type of illness that salmonella will cause. But we can certainly work on how likely are we to find that hazard in my product process combination. Right, so keep that in mind. Now, in the context of risk analysis, there's so many things that we have to do to effectively manage the risk, right? To effectively minimize the risk associated with the hazards that we have identified. Of course, foundationally, we have to assess the risk, and that involves hazard identification, exposure assessment, characterizing the hazard, and of course, then ideally coming up with a risk categorization or with a probability that is numerical. However, the way that we start in practice minimizing the risk associated with the hazards that we have identified is by applying risk management strategies that you can see towards the top of the slide. So when we think about management, we're really thinking about critical limits, microbiological criteria, application of HACCP principles, and of course, foundational food safety management systems such as good agricultural practices, good hygiene practices, good manufacturing practices. All of those things that are going to help us, in theory, minimize the risk associated with many hazards, right? And so then we only want to prioritize for HACCP, we only want to prioritize the ones that carry a relatively higher level of risk. Okay, now I know that this sounds very theoretical. We'll go into a little bit of the application here in a little bit. As most of you know, the microbial ecology of foods, it's very complicated because these are very dynamic and complex microbial ecosystems. Food changes over time. Once you apply a process, as time passes, the microbial ecology will change. And microbes can be introduced at any point in the food production chain, from ingredients and supplies to processing and preparation environments to people, and even things like air, compressed gases, and dust. And so keeping track of all of the sources of contamination and be able to minimize the introduction of microbes through so many sources becomes complicated. But that really has to be part of your risk assessment strategies when you are evaluating what are the chances that microbe or chemical or foreign material XYZ is going to end up in my product and process. Of course, there's many different types of microbes, and the ones that we're talking about today are the pathogenic ones, particularly Salmonella. Now, the other thing that really complicates microbial food safety and managing the risk is the distribution of microbial communities, especially pathogenic communities in foods. We can have, in an ideal world, in a food or a food contact surfaces, food contact surface, regular contamination. And in a regular contamination, like you see on the left side of your screen, basically means high prevalence of the contaminated unit in the lot with low variability in concentration. And so if we take a sample from any of those squares, the chances of getting a positive at roughly the same concentration are very high. And so that's ideal, right? But we don't typically have that kind of scenario. Sometimes we have that in liquid foods, right? Because we can mix them, we can shake them. And so then the chances of catching the defect are higher. But more often than not, we have things like random contamination that you see in the middle, no specific pattern, similar quantitative results, but similar qualitative results, right? Positive, positive, negative, but variable quantitative results. And so we may take a sample that comes back positive, but it's telling us that we have a very low concentration when in reality we have a high one, or the opposite. We take a sample, comes back positive, the numbers are really high, we freak out and we start applying sanitation, enhanced sanitation strategies and whatnot, when in reality, maybe it was just that one sample that was really high. And then, of course, the worst case scenario is this cluster contamination that we see with low prevalence of the pathogen with high variability in the counts. And we see this very commonly in low moisture foods, right? So think about powders such as flour, powder infant formula, things that are fairly difficult to mix after processing, right? Because they settle, they are very tightly packed. And so finding salmonella in these scenarios is very difficult. Now, one alternative to finding salmonella, of course, we want to test and we want to make sure that we have a product that is negative for salmonella with a certain level of confidence, because that's the most we can do, right? We can choose a statistical sample, we can do a test, and then with a certain level of confidence, we can conclude that the pathogen is present or absent from that one lot of product. But of course, from a testing perspective, we rely heavily on microbiological indicators. And many of you, or most of you, probably use microbiological indicators in your companies, in your products and processes, where you choose to test for aerobic plate counts, or coliforms, or generic E. coli, or Enterobacteriaceae, or anything like that, that will be more informative from a quantitative perspective. And then, of course, you complement pathogen testing with microbiological indicator testing. Now, indicators could be of other types, right? We could have enzymatic indicators. We could have ATP, right, as an indicator for the quality of your cleaning. There's a lot of different metrics that we can use and start combining when we know that finding the pathogen is very difficult. And that is the typical case of salmonella. Okay, why is salmonella such a big problem? We're all here today because, of course, we know that salmonella is a huge problem. But let's look at the data, right? So let's look at this document that was published last year by EFSA, and it is an extremely informative document that I recommend to everybody to go and read. It's called "Persistence of Microbiological Hazards in Food and Feed Production and Processing Environments." It's a phenomenal document. And if you guys see here, salmonella is highlighted there towards the bottom. And you guys can see that this is a pathogen of public health relevance in every sector of the food supply. So this is feed, meat, fish and seafood, dairy, eggs, fruits and vegetables, and low moisture foods. And so we know that salmonella can be present in virtually any food commodity, which makes it even harder to manage because it's not only the food commodity, but it could be a number of ingredients that we use in that one food commodity that may be contaminated with salmonella. Now, to complicate things even more, right, with this very interesting microbe, and you see again towards the bottom, it's not only the food that can be contaminated, but it's also the food processing environment. And you see the ones that are in red and yellow, the processing environment of feed, right? So animal feed, food for consumption of animals, the processing environment of meat and poultry products, as well as eggs and low moisture foods, tend to harbor salmonella at higher frequencies than what we find in fish and seafood, in dairy, and in fruits and vegetables, where Listeria monocytogenes is typically the one that it's more prevalent in that environment. You can see that there's many other pathogens, of course, that are listed there, and Chronobacter sakazaki would be another one that we can find in low moisture foods that it's somewhat similar, behaves similarly to Salmonella in those low moisture foods, just in the way that they are able to survive in such very low water activity environments. Now, when we think about low moisture foods and many other types of products, we typically do dry sanitation, right? And so there's no water here. So what is allowing salmonella to survive in those processing environments and potentially contaminating food? right? So when we start thinking about risk management, we really need to start thinking about all of these potential factors, right? And what are the worst case scenarios that we could find or that we can imagine so that we can start addressing the risk. Now, if you've ever taken a food microbiology course, you know that microbial growth and survival in foods is very complicated and it depends on many factors, right? And so when we are thinking from a pure microbiological perspective, we can study all of these factors individually. And then from a practical food safety perspective, we start putting all of these things together for risk management strategies. And hopefully, towards the end of this talk, you guys will see how these factors, interact a little bit. So intrinsic factors, of course, those would be the physical chemical properties of the food matrix, water activity, chemical composition, pH. The extrinsic factors would be things like conditions of the packaging and storage environment, particularly temperature, the presence or absence of oxygen, right? So think about packing food in an aerobic environment versus packing food in an anaerobic or vacuum sealed package, and of course the relative humidity. Now the relative humidity doesn't matter too much for outgrowth of pathogenic bacteria, but it really matters for uh, fungi, right? And the potential production of mycotoxins in things like grains and cereals. Now, the implicit factors are factors that we don't typically talk about, but that really matter. These are microbial phenotypes and ecological interactions, right? So what is the capacity of Salmonella to form biofilms in XYZ type of production environment? What is the capacity of Salmonella to survive an antimicrobial treatment that I am applying based on, genotypic characteristics? And then lastly, we have the product process factors, which are all of the antimicrobials, whether they're physical, chemical, and potentially biological, that determine, partially determine the chances that this microbe is going to be present in the food process, in the product process combination. Now you can tell there's a lot of factors, but this should be ringing a bell to your HACCP systems, right? One of the first things that we do in HACCP is to characterize the physical chemical properties of the food because we need to know if the water activity can serve as a barrier for microbial growth. We need to know if the pH will serve as a barrier, if the chemical composition will serve as a barrier. And from the extrinsic factors, we mostly really want to know temperature, right? What is the temperature at which that product is going to be produced, packaged, stored, distributed? And so all of these things really start playing, interacting together. From a food microbiology perspective, we know that salmonella is everywhere in foods, right? So that's what we mean by ubiquity. It's ubiquitous in foods, in food ingredients, in food environments. So keep in mind that salmonella, it's not just of fecal origin, right? We can have salmonella from many different sources that are not necessarily fecal, right? And so that is a big misconception that we have with many of these gram-negative pathogens, that people will assume that they are mostly from fecal origin, when in reality, we can find them in many other types of non-fecal environments. Now, the water activity, which is of course a measurement of the available water for biochemical reactions in foods and biological systems, is a primary way that we use to minimize microbial growth, right? And so we know that Salmonella grows above 0.94, that it is able to survive in low water activity foods such as spices, powders, peanut butter, chocolate, those sorts of things, beef jerky. The pH of growth it has a really long range, really big range, although of course it doesn't grow very well at the extremes. From a theoretical perspective, Salmonella could be surviving anywhere from 5 degrees to 47 degrees, depending on the matrix, depending on the fat content, depending on um, the water activity of the product, right? So remember that the lower the water activity, the higher the thermal tolerance of Salmonella. That has been proven over and over again. And so if you apply a process, if you start with a fresh product, such as beef, and you are dehydrating that product to produce beef jerky, then you have to assume that the thermal lethality of any residual salmonella is going to increase as the water activity is reduced, right? And so we really need to start thinking about that interaction of factors when we are deciding what is the level of risk that we are going to assign to that product process combination. Lastly, Salmonella is facultative anaerobe, and so it can grow both in aerobic conditions and in anaerobic conditions. So vacuum packing a product, it's not going to fundamentally prevent the growth. It's going to slow it down, but it's not going to prevent it. Now, the message here is know your product and process, and this is related to HACCP. You need to be able to describe the physical chemical characteristics of your product, the storage conditions, the distribution conditions, and any labeling instructions that are needed for food safety. Why do we find salmonella in virtually any product? Well, it's an extremely highly adaptable organism. It can survive in the environment. Epidemiologically speaking, it can be present in humans and many types of animal species. The genetic diversity of Salmonella is gigantic, same with the phenotypic diversity. Basically, the genes that are expressed, right, can allow that microbe or certain serovars and even strains of that microbe to survive better under certain environmental conditions. And then, of course, it may be unusually resistant to heat, to cold, to pressure, to acid, to alkaline solutions, to desiccation tolerance. And this makes Salmonella an extremely versatile organism that it's able to survive in many different types of environments. Now, one point that we need to keep in mind for HACCP purposes and for risk management is the difference between microbial growth and microbial survival. Just because a microbe is not actively multiplying, which is what we define as growth, it doesn't mean that it's dead, right? So microbes can be metabolically dormant and just be surviving. And this is the case of salmonella in low moisture foods, right? So we could find salmonella in things like shredded coconut that has a very low water activity, same with powders and other things, and it can survive for a really long time. Once the conditions are better or improved, then that microbe can recover and cause illness as it recovers, and it goes through the gastrointestinal tract of the host. Okay, so growth and survival are very different things, but they really do matter for food safety. Okay, lots of information, I know, but hopefully you're getting some of this something. Hopefully, I'm telling you something new today. Okay, let's talk about risk factors for salmonella presence in foods, right? So we can split these risk factors into three big categories. We can talk about contamination factors, proliferation factors, and survival factors. Contamination is, of course, the way that the food it's going to be fundamentally contaminated, right? Is it going to be through ingredients? That is very common with things like spices, right? That carry the contamination. It could be dairy powders that are contaminated, and those are going to become an ingredient in the food. It could be things like peanut butter, right? So we've seen peanut butter contaminated over and over again. And peanut butter is one of those things, at least in the US, I don't know exactly in other places, but we eat a lot of peanut butter in the US, right? And lots of products have peanut butter. And so when you have one facility, centralized location that produces a food product that is contaminated, let's say peanut butter, it ends up in so many other foods and products that the recalls that we see seem to be so much bigger. But it is mostly because that one product was distributed to many facilities and brands. One thing that we really need to keep in mind is recontamination and what are the chances that my product is going to be recontaminated after the application of an antimicrobial intervention. That's something that we typically miss when we are working on HACCP. So every time that you work on your flow diagrams and are doing or you work on your HACCP reassessments, at least annually, hopefully, you're going to be evaluating potential for cross-contamination and recontamination of that product after the application of antimicrobial treatments. Now, the second type of factor is proliferation, and this is mostly growth under conditions of temperature abuse. We'll see that here in a little bit, a little more. And the survival factors, which could be in the product or in the environment. Right? Survival factors in the product would be assessing things like, do I have a product with a much higher fat content, and could that fat content protect that product during thermal lethality steps? And then we can find that pathogen later on in that product. Same in the environment, right? What are the chances that my environment has salmonella? How many samples do I need to take Well, that's $1 million question, right? It should be more than 1 million. 1 million is not enough for that question. It should be a $10 million question because it is extremely difficult to tell a processor how many samples they have to collect without knowing the history of that product and process, without seeing the facility, without seeing the quality of their good manufacturing practices and sanitary practices, right? So these are questions that are much more complicated to answer than what they may seem. So let's expand a little bit on each one of these factors. And I know that there's a lot of content on this slide, but I'm going to go through each one of these points fairly quickly. So one of the risk factors could be contamination by a food or non-food handler, worker, or preparer who was suspected to have an infectious illness. Right? This is very common. This is actually very, very common, especially for retail and food service settings where it is the worker that is contributing contamination. And so having clear, enforceable exclusion and restriction policies is the best, really the best practice to manage that risk factor. Now, it could be that we have contaminated raw product. The food was intended to be consumed raw or undercooked or under process, and that product is contaminated. That is the typical case of salmonella in fresh produce, right? In fruits, vegetables, leafy greens, herbs and spices, or mostly herbs, things like that, where a product is intended to be consumed raw and the product was actually directly contaminated. That contamination typically comes from the farm, right? So what supply chain controls can we apply to minimize the possibility of a raw product or of a product that it's intended to be consumed raw to be contaminated? Now, we advocate all the time for consumption of fruits and vegetables, fresh fruits and vegetables, because nutritionally they're good. But the consumer also has to be aware that they are not inherently safe, right? And that a lot of the responsibility falls on the farmer. So keep that in mind. Okay, another factors would be foods originating from sources shown to be contaminated or polluted, right? So it could be water, irrigation water, harvest water. It could be ponds where we grow, let's say, I don't know, tilapia or salmon, right? What are the chances that those waters are going to be contaminated? And then keeping track with any food safety alerts, especially if you work in this environment of global food safety where you are sourcing ingredients from so many places. Okay, contaminated product. This one was food that was intended to be consumed after a kill step. And typically, the way that the food gets recontaminated after a kill step or a lethality step is through environmental contamination. So then this is the point where pathogen environmental monitoring becomes particularly important, especially for foods that are going to be exposed to the environment after a lethality step. And number five, it's pretty self-explanatory, but cross-contamination of ingredients, right, from raw to cooked, processed to minimally processed, anything like that. Okay, now when we think about proliferation risk factors, these are typically temperature abuse conditions. And when we think about temperature abuse, of course, are conditions under which we leave the product um, for excess period of time between 5 degrees and 60 degrees. Okay. And so I'm going to give you an example of things that we do in my lab to study these proliferation risk factors. Many of you have probably heard of um, pathogen predictive modelings, right? Pathogen predictive models. So you can use things like Combase and the pathogen modeling program from the United States Department of Agriculture. Excuse me. And so I'm going to give you an example here. We studied the growth of salmonella in ground pork under dynamic conditions of temperature abuse. And this is work from one of my former PhD students, Manuel Hag. And so the whole point of investigating how microbes grow in a specific matrix under multiple conditions of temperature abuse is to help develop microbiological criteria for products and processes. So if I know that my process allows the product to be exposed to abusive temperature for X amount of time, I have to be aware of by how much the pathogenic organism of interest, in this case salmonella, is going to grow. Okay, so we're not going to go into details of any of these studies, but if you're curious about any of these things or have more questions, of course, you can reach out to me at a later time. But this is just to tell you that there are tools out there. And when we generate this data in the lab, in academic labs or in government research labs, all of these things can be incorporated into Combase or PMP and multiple other pathogen predictive modeling databases for processors to use. Now, importantly, the other thing that we do is to estimate theoretical minimum temperatures for growth. So in this case, we established that theoretically, Salmonella could grow between 5 and 6 degrees Celsius in raw pork, okay? Even if it grows very slowly, but theoretically, that is what we established. Now, we still have to validate that, and there's people in my lab currently evaluating or validating growth, no growth predictive models for salmonella in raw chicken and raw pork at low temperatures, because we really need to validate that this is a scenario that can actually happen. And if at the end of the day we conclude that salmonella can grow at such low temperatures, then our risk management strategies need to really emphasize the fact that we typically use refrigeration as a way to delay microbial growth, but a pathogen like this in this specific matrix could still grow. And so all of those things, as you guys can tell, to make foods risk management decisions and develop these microbiological standards and all of these things, we require a lot of data. And so in academic labs, we develop a lot of that data. Okay, let's talk about survival risk factors, the third survival strategy or risk factor that I want to emphasize. And these are typically insufficient time, temperature, or both during cooking, processing, or reheating, right? So that is basically you did not reach sufficient temperature to eliminate the hazard that you were looking for, especially salmonella, right? Because salmonella is the hazard that we use as the standard for thermal lethality studies. And we mostly assume that if you're able to eliminate salmonella from a product and process through a lethality step, that you're going to be eliminating listeria, pathogenic E. coli, and others. The second risk factor here would be insufficient or improper use of chemical processes designed for pathogen destruction. And this is again not validating lethality or chemical effect of those antimicrobials on the pathogen. And this leads us to the point of growth versus survival, right? In the US, for example, and it might be the same in Europe, we have situations of insufficient time and temperature during cooking of rotisserie chickens, right? So rotisserie chickens are the ones that are rotating, of course, and get roasted. And we can also do that with pigs, right? We can have smaller pigs that are rotisserie pigs. And so there's been instances where we know that the time temperature combination for that is not sufficient to eliminate salmonella that could be, hidden deep inside of that animal tissue. And so that is a survival risk factor because at the end of the day, you cook that product, you assume that you achieve thermal lethality adequately, and then somebody can still get sick with that residual salmonella that was left. Now, the examples that you see on the bottom are chemical interventions, and we do a lot of those things in my lab. So all of these three examples come from my research team. And this is basically evaluating chemical processes, right? And determining if alternative chemical interventions, including clean label antimicrobials, are as effective as industry standards, at least in the US, such as peroxytic acid and lactic acid, at eliminating microbes from, in this case, raw chicken products. I know that the regulations and the use of chemicals in poultry processing are very different in Europe than what they are in the US. You guys know that in the US, we put a lot of chemicals in our chicken, right? So I'm not saying it's a good thing, but I'm saying we need to have validated information as to whether those chemicals actually work. And so we do a lot of that work here in my lab at the University of Nebraska. Now, a couple other examples, right? So I was telling you about thermal lethality. So this one is salmonella destruction in air frying operations, and this is particularly important for retail and food service, right? So, well, or people have air fryers at home. Pretty much everybody. Well, I shouldn't say everybody. but it is very common now to have air fryers at home. So the information about Salmonella thermal lethality for air frying operations is very lacking. So we conducted this study. This was a former student of mine, Carmen, um, that conducted this study so that we would evaluate and compare Salmonella destruction on chicken wings cooked in domestic convection and air fryer ovens. And at the end of the day, we do the inoculation studies, we do the thermal lethality studies, we do all of the math for the thermobacteriology. So we determine D and Z values and F values for cumulative lethality. And we conclude, of course, that at the end of the day, the cooking time is the was the most important thing, right? So if we follow the regular practices that the manufacturer of the air fryers tell us to follow with a common recipe, it is typically the cooking time. Now, air fryers get really hot, right? And one of the reasons why we do air frying is because we can get to really high temperatures by in protecting the quality of the product in the way that we cook it. And that is one of the reasons why we use it so much. But the other example that I'm going to give you here is sous vide, right? And sous vide is another operation that is extremely popular. We go to the supermarket and we can find products that have been sous vide, right, and commercially produced in sous vide, conditions. And so in this case, there is a lack of information for sous vide as well. And what we wanted to know was if the time temperature combinations that are provided by the USDA Food Safety and Inspection Service would be applicable to sous vide, right? Because we typically use that for an actual cook step. And sous vide is a cook step, it's a thermal lethality step, but we really needed to validate it. And what we found here is different than what we found in the air fryer, because the air fryer does get to a really high temperature. And so it is a matter of how long you keep it, right? In this case, for sous vide destruction of salmonella, and this one was in beef, I want to say, yeah, in non-intact beef, cooking temperature was the most important factor because a lot of people will try to cook, quote unquote, cook meat in sous vide operations and many other different types of operations by leaving that product for a really long time in that operation at a low temperature. And so we validated that some of the commercial recipes that exist do not achieve thermal lethality, and that clearly poses a risk to the consumer. Okay, I know this has been a lot, but hopefully informative. So let's get to these final remarks, and then we'll get to the questions that I'm excited about. So the first, I guess, recommendation that I have for people is know your product, process, and supplier, right? So this is the application of food safety management systems such as HACCP. You really need to know what is happening in your product and process. Now, you keep hearing me say product and process, right? Those two things go hand in hand, right? We cannot really isolate those two because there are hazards that are more likely to happen in a product process combination than in others, right? So we cannot just say, um, let's say, air fried chicken, or we cannot just say chicken, right? So it would be air fried chicken. It would be sous vide chicken, right? So those are product process combinations. We have to validate critical operational parameters to ensure microbial food safety. And that is a big failure that we see when we do HACCP audits, right? So people have established operational parameters that have not been validated or are not adequate or fit for purpose of what they have in their process. We need to design and execute solid environmental monitoring programs, and this is particularly important for when an environmental pathogen such as Salmonella is likely to be present and contaminate product after thermal lethality. We want to define microbiological criteria for internal uses, right, for risk management strategies and to support HACCP decision making. And like we saw earlier, microbiological criteria is difficult to define, right? There's a lot of resources out there, but it has to be specific to our product and process. Expand traceability and information systems, and that is typically to be able to catch issues much earlier. And the last thing is the only thing that I'm going to say about testing, although I know that the title of this webinar was Better Testing and Risk Management. but I would rather emphasize risk management and less on testing. Why? Because industry over relies on testing, and testing is very important. We have to test ingredients, we have to test the environment, final product, in process product, um, lots of different things, right? So that we can have a really good picture of what is happening. But testing in itself is not an antimicrobial intervention. And so we typically see this very reactionary response to testing. We tested for something, we found a hazard, let's say a pathogen like salmonella in the environment, and then we enhance sanitation, we enhance testing, and then maybe the corrective action that was taken was not appropriate, and then the issue is going to repeat over and over in the future, right? So avoiding over reliance on testing, and just keeping in mind that testing is a verification activity, that you still have to do all of these risk management strategies first and use testing as a way to verify the effectiveness of your antimicrobial interventions and your food safety risk management strategies. So with that, I am going to close and take any questions. I really appreciate your time and attendance this morning. And like I said, feel free to reach out to me separately. My email is on the slide right now. And I'll stop sharing so that we can go to the questions. Thank you very much.
Thank you so much, Byron. And I should say that we already got some questions, but before I will read it out, I would ask you guys the thing what I actually typed in the chat room, that if you found any of the slides super attractive, or you want to say some kind words to Byron and to Nemis Academy, you can post it to your LinkedIn, tag me, Nemis Academy, and Byron if you want, and Byron if you don't mind. And
Absolutely. Yeah.
yeah, definitely. And as the thank you from us, you will receive a promo code for our exclusive 1 day training, which is really super important, as Byron also indicated about HACCP, food safety and risk management. So don't miss this opportunity. So, are you ready, Byron, to answer the
Yeah,
questions?
totally.
Okay, perfect. So the first one, how effective is PPA as a salmonella antimicrobial, and what is the correct concentration to avoid chemical contamination risk?
Yeah, great question, right? So they're not specifying the matrix, right? So it would be much different if we're using PAA on produce, where the concentration would have to be much lower. But let's assume that they're talking about chicken for now, right? So you would have to look at your national regulations first. In the United States, for example, we can use peroxytic acid up to 2,000 parts per million. However, that is extremely high, right? So from an occupational perspective, that is not good. You walk into a facility where PAA is high and you can smell it and your eyes will also feel it. So we typically go from 450 to 700, right? So again, you have to find the validated information that it's applicable to your product and process. One thing that I would say is that is a concentration that we have proven effective for chicken, for example, chicken carcasses and chicken parts, but it may not work in beef, right? So you cannot assume that one chemical concentration will be effective against that same pathogen in a different matrix, right? So you still have to look for that validated information.
Yeah,
But
definitely.
PAA is
Thank.
very effective. PAA is the most effective of all of the antimicrobials that are out there, plain and simple.
Yeah, good. Next question is, what source of validation control measures do we account for when we prepare a HACCP plan?
Yeah, okay, let me see if I understand the question. So validation control measures, okay. So maybe the source means the actual technical references, right? And so then I would say look at guidance documents, right? And a lot of those guidance documents can come from national governments, right? Particularly in Europe, as well as EFSA and many other international organizations such as FAO, right? In the United States, of course, we rely heavily on guidance documents from the USDA, but also from professional societies and commodity boards, right? So if you have let's say, Pet Food Producers Association, just to give you an example, I'm making this up, but Pet Food Producers Association or almond milk producers, like they will have internal guidance. And so if that is a product that you're working with, I would advise you to look at the guidance that it's very specific for the food commodity that you're manufacturing. And I can
And
always, I'm sure that Alina would be the same, but we can always point you towards the right direction with information.
yeah, definitely. And if you don't mind, Byron, I will refer people to your LinkedIn
Mhm.
profile also. If they want, they can ask you some other questions
Absolutely.
afterwards.
Yeah.
Next question. What are places and machine parts in the food factories posing the highest risk for salmonella persistence?
Yeah. Um, Great question, right? And so then, you know, um, let me try to make this answer more concise in my head before I give you the answer. So, number one, it's hard to tell without knowing any other context, right? Because if we're thinking meat and poultry, and if we're thinking low moisture foods, and if we're thinking fruits and vegetables, those would be different surfaces that are going to likely contribute to environmental contamination. Regardless of the surface, whether it is an assembly table or whether it is a dispenser of liquid or whether it is a conveyor belt, right? Anything like that, you have to do those assessments for your own company. Now, the way that we do that is by first, when you are developing an environmental monitoring program, you have to do a lot of testing. And this is basically the testing that allows you to identify what are the sites within your facility that are more likely to harbor an environmental pathogen. And then you can go from there, right? But first, you basically have to map out your facility, take a lot of samples, and identify the potential niches. Now, what are some really good places to start, right? Not particularly in the case of salmonella, but if you're working with listeria, would be drains, right? And then anything that has a crack, anything that has cracks and tears, anything like that where you can hide moisture, organic material that can serve as a substrate for microbial survival over time. So then you definitely want to start in those specific sites.
Thank you so much. I should say that maybe I will ask a few more minutes to stay because there are already so many questions.
Yeah.
Yeah. Next one. Is there any regulations in US regarding level of salmonella in food ingredients? We receive more and more requests from companies to have stricter limit in food ingredient. For example, ABS in 25 grams to ABS in 375 grams.
Yeah. So I would say no. So right now, the only one, well, of course, ready to eat foods, right? But that would be the final food. The other recent regulation in the US for that declares salmonella as an adulterant, right? And so when something is an adulterant, you cannot put that product in the market or have to recall that product from the market. Would be salmonella in breaded stuffed chicken products, right? So that is a very recent regulation, and so now we cannot have salmonella at any levels in those products. But other than that, it is up to really the supplier customer relationship to establish a lot of that microbiological criteria on what it is safe to use. So if you want to use spices in a product after that original product has received a thermal lethality step, you better make sure that your supplier is providing you with spices that have been irradiated and heavily tested for salmonella, right? Because you don't want to add a product that it's ready to eat to another ready to eat food product that it's going to be potentially contaminated with that ingredient, that ingredient is going to be contaminated, right? So I think that it puts a lot of pressure on the supply chain controls and the communication that you need to have with your suppliers. Now, we obviously know that food and food ingredients come from many different places in the world. So even if you don't have direct access to the manufacturer, you probably do have direct access to the importer, right? So the person or the entity that is importing a food product from another area of the world, right? And so you still have to make sure that they are compliant. by receiving certificates of analysis and letters of guarantee that can support your food safety decision making for supply chains.
Yeah, thank you so much. Next one. In the UK, livestock are typically vaccinated for Salmonella species. Does this mean that any Salmonella found in finished product will be from user contamination, or are there reservoirs that can withstand 72-degree pasteurization of dairy produce?
Yeah, when we vaccinate cattle, and it could be the same with chicken, which we do, we don't have a universal salmonella vaccine, right? So it is a vaccine that is specific for serotypes of salmonella, right? And so because we have a huge generic diversity, the reason why we can't have a single vaccine is because genetically speaking, is salmonella is very complicated, right? There's so many different types. So yes, does it contribute? These are pre-harvest interventions that do contribute somewhat to minimizing the risk of carriage or the risk of shedding salmonella um, through feces or anything like that. And so ultimately adds to the risk management strategies from farm to table. But it is not, we cannot just rely on that one because we know that it is not, of course, 100% effective, that there's only certain zero bars that are targeted. So I would say that first thing. And then Alina, remind me the second part of that question.
The second part was about, one second, was about are there reservoirs that
Yeah.
can withstand, yeah,
Yeah.
72 degrees pasteurization of dairy produce?
So very unlikely, although there is one zero bar of salmonella that it's called Salmonella Septemberg that is the most thermal resistant, but it is a very kind of worst case scenario. We don't find that microbe very often, and it's only certain strains of Salmonella Septemberg that are actually highly thermal resistant. But it could be the same with any other environmental stress. We can find strains of any microbe that are unusually resistant to acid, to cold, to heat, to sanitizers, right? So we cannot just single that out because um, we cannot really define risk management strategies based on that, just that one really worst case scenario, right? Because it would completely overestimate the risk. So I would say it's unlikely to survive pasteurization, right? So if you have an adequately validated pasteurization process, especially for a matrix that it's so easy to treat like milk, it's unlikely.
Yeah, definitely. Unfortunately, not everything is under control.
Yeah.
Next one. We are a company that receives raw meat materials and we do cutting, mincing, and freezing the meat. As you can see, there is not much we can do by means of killing or reducing salmonella contamination in our meat. So there are two questions coming. First one, what are the most critical factors we can do to reduce salmonella risk besides supplier and hygiene monitoring? And how frequently we need to monitor our environment for this salmonella? So
Yeah, I would say no. Yeah, no, it's a good question. I would say the most critical factor there, because you receive the meat, you cut it, you mince it, presumably you pack it, maybe freeze it and ship it, right? Or maybe it's never frozen. So then the temperature in the cutting room will become a critical aspect of your food safety management system, right? So when you do the cutting, you really need to monitor by how much, you put the meat out of the fridge and you have a table, you're mincing the meat, you're cutting the meat. Um, you need to monitor by how much the temperature of that meat is actually increasing, and then have a decision process and say, okay, I can have this meat for, let's say, 1 hour outside of the fridge before it reaches this one temperature. And my corrective action is, let's say, measure after 30 minutes. And if it's getting to that value, we put it back in the fridge, right? So you have to kind of make an assessment that works for your operation. In a product like that maybe doesn't have an antimicrobial intervention, you're just relying on maybe some testing, sampling and testing from the supplier, then temperature control is particularly important. Something that I will say about temperature control is that if you choose to include, if you're designing a HACCP plan and you choose to include refrigeration as a temperature, as a control or as a critical control point, you have to be aware that refrigeration is not killing any microbes, right? It's only preventing the risk from increasing, but we are not actually minimizing the risk by refrigeration, right? So you cannot really rely on refrigeration, not even on freezing, to kill bacterial pathogens.
Thank you so much. Next question. What are the benefits of conducting a risk assessment for food testing, particularly for Salmonella, given that its criteria are based on presence or absence without specific limit thresholds?
Not sure that I fully understand the question, but if we think about setting, a risk assessment for testing, I don't know exactly what that means, but but if you go by presence absence, your decision to go by presence absence, it's mostly based on the risk associated with the product under consideration. So if you have a product that you manufacture for hospital cafeterias, let's say that you have a contract for hospital cafeterias, or you have a contract for school cafeterias, then you know that the audience is very high risk, right? And so then you might want to have a microbiological criteria that is just a presence absence. However, if you're selling this to the general public, right, depending on the type of product that it is, and if the product does not support the growth of the microbe during market state, right, so during the shelf life of the product while the product is exposed to the consumer at the store, if that product does not support the growth of the pathogen, then you might have a different microbiological criteria, right? You may want to quantify. It will also depend on how difficult it is to quantify that microbe in your product. If what you have is peanut butter or chocolate or anything that is really fatty, right? Those are complicated matrices, right? And so detecting salmonella, it's very difficult. You may need to rely much more on microbiological indicators for process control.
Thank you so much. Next question. First of all, greetings from Fremont, Nebraska to you.
Oh, nice. Thanks. Hi.
Yeah, and the question is coming the following. Biomapping sampling as a salmonella tracking, identification tool or action plan?
Biomapping is becoming so incredibly popular, right? And it does give you information. The one thing that I would caution for biomapping is that number one, you need to know how to analyze the data because you're going to spend a lot of money going around sampling everything, every step of the process, and you're going to have a lot of data. So then the question is, what do you do with the data? Do you have a way to analyze it, to turn this into statistical process control for decision making, right? Those sorts of things need to be addressed. So I would say biomapping, really important. You can make decisions for quality purposes, for safety purposes, to see where contamination is being introduced and where controls can be better applied. That's caution number one. Caution number two is um, biomapping is microbial characterization of a food environment at a single time point. So if you don't have consistent sanitation strategies, your biomapping results are not going to be particularly useful in the future. Because if you have inconsistent sanitation, you biomap your facility today and spend a lot of money to make decisions based on those results or over a period of time, and then your sanitation crew changes and your sanitation strategies changes, then the results may not be applicable, right? So you have to be really careful about data use and consistent sanitation practices. But it is definitely a tool that people are using and it can be very informative.
Thank you so much, Byron. And as far as we have 1 minute left, I'm really curious to ask you like my favorite question. How do you see the influence of current technology uh, for like to improve in better traceability and maybe in general information systems to enhance food safety?
Yeah, that's a great question. I love it because we were having this discussion in New Mexico this week, and um, I'm gonna give you the example of writing a HACCP plan using ChatGPT, right? And just like many other tools, AI, of course, is a tool and we can use it and we should be using it. But I'm going to caution you not to rely heavily on it, right? You still have to have expertise. When we write HACCP plans using ChatGPT, I would say we are less than 40% accurate, right? So it can give you a start and you can use those sorts of things and it's fun. You can go and play with these tools, but you have to be aware that ChatGPT doesn't know your product and process, right? And so you still have to have that human component of decision making when you use some of these technologies.
Thank you so much. And we should not be scared to be replaced by AI,
No, not at
right?
all. At least not in food safety.
Yeah, definitely. Thank you so much, Byron, for joining us today as a speaker. Thank you to everyone who joined us today as attendees. Follow us for further webinars. Follow us in LinkedIn. Follow me, follow Byron, and in general, don't hesitate to ask questions if you have some. And I'm really welcome you to submit for other webinar, which will be already next week. And there we will talk about more innovative technologies in food safety. Have a nice day to those who started the day. Have a nice evening to those who ended his working day, and see you in next webinars. Bye.
Thanks.